We are given three lines x plus y equals to 1, 2x plus 3y equals to 6, and 4x minus y plus 4 equals to 0. Then, where does the orthocenter of this triangle lie? Obviously, there are three lines, and all three, these are not parallel lines. So, these three lines will meet somewhere and they will form a triangle. These are not parallel lines, right? So, somewhere they will meet and they will form a triangle. What happens to the orthocenter of this triangle? This triangle can be acute, a right angle, or an obtuse angle triangle. If it is acute angle triangle, orthocenter will lie inside the triangle. If it is right angle, then at its vertex, right? Orthocenter will lie at its vertex. If it is an obtuse angle triangle, it will be outside the triangle, right? So, what is orthocenter? Orthocenter is actually the meeting point of perpendiculars drawn from vertex to the opposite side. Perpendiculars, right? So, ortho means straight. Ortho means straight or right or whatever. This is a Greek word. So, perpendiculars means the straight lines drawn from vertex to the opposite sides. So, for example, orthopedic. Orthopedic is the doctor who sets the bones straight. So, that's why is the orthopedic or orthodox. Orthodox are the old beliefs. So initially, the old beliefs are supposed to be the true beliefs or the right beliefs. Orthodox beliefs, in the traditional sense, the more religious people, they are supposed to be the ones who have the right beliefs. So originally, this the word was created that way, orthodox, right? So in this case, orthocenter. Orthocenter is about the perpendiculars. The perpendiculars are the straight lines, the right lines. Straight lines are right lines. Right lines means right angle lines. Those are drawn from vertices to the opposite sides. This word has got some Sanskrit connection also. In Sanskrit, it is called urdhva. Urdhva is upwards or straight or upright, whatever. So ortho and urdhva, these are somehow related. Okay. So now this word is actually Greek word. Now in this case, we have three vertices, right? These three lines, if we solve, we'll definitely get three vertices. Okay. So let us, when we solve, these lines are like this, right? X plus y equals to 1. Obviously, that line is this one. X plus y equals to 1. That is this line, right? Obviously, slope is equal to minus 1. Now, 2x plus 3y equals to 6. 2x plus 3y equals to 6. That is this line. 2x plus 3y equals to 6. That is this line, right? And what is the third line? 4x minus y is equal to 4x minus y plus 4 equals to 0. Obviously, this line has got a positive slope. That is this third line. The slope is positive here, right? Y equals to, the slope is actually equal to 4, right? Y equals to 4x plus 4. The slope is 4. So this is a positive slope line. That is this line. Two lines have negative slope and this line has a positive slope. Now, what happens to the orthocenter of this triangle? And where exactly is this orthocenter located? Let us try to calculate the orthocenter itself. So let us assume the orthocenter has got some vertex h comma a, and we have this triangle A, B, C. Obviously, the lines are meeting, right? This line is meeting these two lines at these 2 points, B and C. And at the same time, these two lines are meeting at this point A, right? The line 4x minus y plus 4 is meeting these two lines at B and C. These two lines are x plus y equals to 1, 2x plus 3y equals to 6. Those are these two lines. And 4x minus y plus 4 is this line, is this line. So all 3 points are this. If we solve all these three lines, if we solve 2 together, for example, x plus y equals to 1 and 2x plus 3y equals to 6. If we solve these two lines, we are getting this point minus 3 comma 4. And if we solve these two lines, 2x plus 3y equals to 6 and 4x minus y equals to 4. That is, then we are getting this point minus 3 by 7 and 16 by 7. And if we solve these two lines, um, sorry, when we solve 2x plus 3y and x plus y, this is done. Then we solve this one and this one. X plus y equals to 1 and 4x minus y plus 4 equals to z, we'll get minus 3 by 5 and 8 by 5. This is plain simple solving two lines at a time. Right, we have got three vertices, minus 3, 4, minus 3 by 5, 8 by 5, and minus 3 by 7, 16 by 7. Now we have to find where exactly is this orthocenter. if we assume that HK are the is the coordinates, HK is the orthocenter, then what does that mean? This orthocenter, if we call it as O, then what does that mean? This means if you draw a perpendicular from A to the opposite side, that is BC, right? So this BC, if we extend it, and if you are drawing a perpendicular from A to BC, right? If you draw a perpendicular from A to BC, or if you draw a perpendicular from C to AB, C to AB, right? So that is from C to AB. If it that is this perpendicular, or if you draw a perpendicular from B to AC, right? That is AC is here and B to AC is this perpendicular, or this perpendicular, this perpendicular, and this perpendicular, each from one vertex to the opposite side, extended opposite side. BC is extended like this. So this perpendicular from A to BC is going like this, and C to AB, right? C to AB is in the triangle, right? This perpendicular is going in the triangle, but extended other side also, and B to AC. AC is extended like this, and a perpendicular is drawn from B to AC. These all three are meeting at this point, right? Obviously, what does that mean? The slope of this line OA and the slope of BC, these should be perpendicular because or sorry, AO and BC, A should be perpendicular to BC. Right, if we assume HK as this point, then what does that mean? OC, the slope of O and C. O and C, the point C is minus 3 by 7, 16 by 7. So that means K minus 16 by 7 by H minus 3 by 7, that is H plus 3 by 7, into the slope of this line. Right, the slope of M equals to this line, right? So this should be perpendicular to this one, right? And the slope of this line is minus 1, right? So this line is perpendicular to this line, and this line slope is K minus 16 by 7 and H plus 3 by 7. The product of these slope should be equal to minus 1. Then if you simplify this, we are getting this one, this relation between H and K. H minus K equals to minus 19 by 7. Similarly, this one, if you take this point, OA, OA should be perpendicular to BC. OA, sorry, O is, so earlier we had taken the OC is perpendicular to AB, right? This one OC is perpendicular to AB. Now we are taking OA is perpendicular to BC. OA is perpendicular to BC. What does that mean? The slope of this one and slope of this one, product of that should be equal to minus 1. What is the slope of this one? K minus 4 by H minus 3. That is this one. Into what is the slope of this one? The slope of this one is M equals to 4. Right? Y equals to Mx plus C. So these two products should be equal to minus 1. And if you simplify this, we are getting H plus 4K equals to 13. We have got two equations and two variables, H minus K and H plus 4K. If we solve both of them, we are getting 3 by 7 and 22 by 7. So this point is actually 3 by 7 and 22 by 7. Right. So the ortho center is actually lying in quadrant 1. So Q1 is the correct answer. Right, guys?